think we're live.
All right, we are live. Welcome, everyone. My name's Eric with BobCAM. We have
Welcome.
Tatiana.
This is Tatiana Rojas. I'm the VP of Sales and Marketing here at BobCAT, and I decided to participate on this webinar so we can have more of a conversation about what we're looking at here, what we're doing, instead of just Eric talking to himself. And of course, we invite each one of you to participate. Please send us your questions, send us everything you need. So the more you guys participate, the more you guys chat with us, the better it's gonna be. So we both have the chat open right now. If anybody has a question or if maybe you can't hear us, if everything is good, let us know, please. And Eric, tell us a little bit of what are we going to be doing today?
Yeah, so today we'll be looking at the differences between the CAD system with SolidWorks and our standalone version of BobCAD. Our standalone version is V37, and our plugin for SolidWorks is V12 BobCAM for SolidWorks. So we'll be looking at the CAD system of SolidWorks and how it relates to the plugin, the CAM programming package that we offer, BobCAM for SolidWorks V12.
Okay, so just to give you, I think this is the most important question here that we're trying to answer. I'm a customer. I'm looking into Bobcat or looking to operate in Bobcat. Um, why would I think of maybe working with SolidWorks instead of Bobcat? Why would I make that decision?
Yeah, good question. So the best way I explain it to customers would be that our standalone version, BobCAD version 37, we
Mhm.
have been in business for 37 years, and throughout that whole career of our business, we have been focused on the CAM programming side of it to make sure
Okay.
that the machinists are able to create the specific G code that they need. Uh, and the difference between our CAD package and SolidWorks CAD package is SolidWorks within their whole career of doing business. They have focused on the CAD 3D modeling side of things much more intensively, and they just started to come out with a CAM programming package. So it's sort of in its infancy. So I would say the biggest advantages would be SolidWorks has the advantage with CAD, and BobCAM has the advantage with the CAM programming.
So we will think that. So why would a customer will go with with SolidWorks instead of Bobcat? What would be the scenario for that to happen?
The scenario would be probably a much more complex shape than this that we have on the screen here. This is a very basic shape, basically just creating a couple sketches, doing an extrude boss, and then an extrude cut for the pockets on the inside here. This
Mhm.
could very easily be achieved in the BobCAD CAD software program as well as SolidWorks. But if I get into some of my other files here, like go to my demo files, and something like this, 3-axis, 5-axis, something like this model with contours and things like that to be able to create a very complex 3D model like this could much more easily be created in SolidWorks to utilize the sketching and surfacing functions that SolidWorks has to offer.
Okay, so to be clear, you could do this in Bobcat and you could do it in SolidWorks. It would just be easier to be done inside of SolidWorks.
Yes, that's correct.
Okay, perfect. So show us a little bit of what you got on SolidWorks.
Absolutely. So we'll get started here with this model. And for our V12 BobCam for SolidWorks customers, this is actually a file that you could follow along with. If you go to your file explorer, I can show you the file path because this file is downloaded with the software program V12 BobCam for SolidWorks. If you go to your this PC under your file explorer. You go to your C drive, BobCAD CAM data, and BobCAD CAM V12, or an older version of BobCAM for SolidWorks. And you go to your examples folder. These examples files here are all preloaded in the software program. We go down towards the bottom where we have this pocket example, and that's where this file is opened up from. So basically, we just created uh, a basic sketch of a rectangle here. And to show you how easy it is for the drawing and 3D modeling in SolidWorks, we can see that here by going to a new file, and how we created it, that example file. We went to the sketch tab up at the top in SolidWorks, and we created a basic sketch. We did it on the front plane. I'm more familiar with creating it on a top plane and then extruding it down so that everything correlates with the machine setup and things like that in the milling job later on. So I'm going to go into a top plane, create a rectangle. And so this most common option, if we go down to the drop down, there are many different sketching options for a rectangle, but the main one here is creating one corner of the rectangle and creating a second corner of the rectangle to create my basic shape there. Then we can go about creating the sketch by creating the dimensions of the sides of the rectangle by
So you
going to
could
the
say
top.
that that's very different to our Bobcat workflow,
It is,
because
yeah,
In Bobcat we will define the dimensions and the codes as we're drawing the rectangle, right?
right. Yeah, with that's a good point. With SolidWorks, you're just basically putting down a basic shape of your sketch and then going back into it and modifying the dimensions afterward.
Okay.
That's a good point. In the Bobcat standalone version, a little bit different workflow. You are typing in your dimensions of the size of the rectangle and placing it down where you want to, and then and then there are other options of modifying it afterward, but it's usually not the the
Norm.
common workflow.
Okay.
Yeah, so we go to our smart dimension up at the top here in SolidWorks. And you can see actually a couple lines here. The one on the left and the one on the bottom are black, and the one on the top and the one on the right hand side are blue. Now, the black lines, the term in SolidWorks means that they are defined, and the blue lines here mean that these lines are underdefined. So what that means is these lines here, if I go out of my smart dimension function, I'm always in my select mode, more or less, in if I were to use a term for BobCAD, I can always click on a line and change it, double click on it, or I can drag it over. Now with the black lines here, I'm not able to move at all because they are defined. They are sort of fixed there. They're fixed at the origin location of where I placed it down at the bottom left corner,
Okay.
and they're also fixed based on the length of them. So now I can only change the top and the right one. So when I click and hold, what I normally do in SolidWorks is I will click and hold and drag something around to see what makes these lines underdefined. So I
Okay.
can so I can drag it over and I can see, okay, what makes them underdefined is this point right here and also the length and width of it. So I can go into my smart dimension and I can click on the top line here. It says that the dimension here is 4.36. I can click above it here and it asks me for the dimension that I actually want after I've sketched it. So I'm going to make this an even 4 inches and click OK. And then now the only underdefined one is the top line here. And the reason for that is because I can move it up or down to change the the width, you could say, of the rectangle. And so now I go back into my smart dimension, click on this line, and I'll make this 2 inches. So 4 inches by 2 inches there. And then afterward, to get out of the sketch function, I go to the top right here, and there is this OK option or confirm option here to click on. Now we have this feature tree, which is similar
So
to the CAD tree in the
just to
BobCAD
ask you,
workflow.
you
Go ahead.
could create relationships between geometry, right?
Yes.
Because
Yep.
like let's say that line, the black line that we had on the right hand side had
Hmm.
a direct relationship with the, or it's totally parallel to the other one.
Right.
So they're parallel to each other, and when I change one, the other one changes automatically.
Right.
Is there
Yep.
any way to unlink that? So let's say I don't want my right line not to be parallel to the left hand one.
Hmm. Yeah,
Okay.
good point. I can double click on the sketch now that I'm back in the feature tree in SolidWorks. I can double click on it, I believe, to modify it. Oh, yep, I'm back in it here. And, right, or I can right click on it and go to edit sketch. And then I'm back in the sketch function. You can see these are the relations right here, these green icons, just as you mentioned. These are saying that they are vertical lines. I can double click on one of these and I can get rid of that relationship by right clicking on the vertical component here and deleting that. So now I can actually click on this point. I should be able to click on the point now. And now I can move the line so that it's not vertical anymore.
Okay. So reason I asked this question is because this is one of the big differentiators that SolidWorks has to offer,
Hmm.
um, and is that you are able to create relationships between geometries. Therefore, the parametrization process of once you build something more complex, it's easier to come back and modify it. Is that
Yeah, that's a great point. I think that, as a side note, I think that Bobcat has done a great job of sort of advancing their technology in terms of parameterizing their sketches. You can now double click on a line in BobCAD and be able to modify the entity. Just a little different workflow than here in SolidWorks. But yes, with the relationships with these green icons showing that they're horizontal or that this point right here is coincident to the CAD origin location, they're very easy ways to be able to change the relationships to anything within the sketch of SolidWorks here.
excellent? Okay, keep going. I just thought that relationships was something that everybody should understand when just getting into SolidWorks.
Yeah, absolutely. And then I could even go back to making them vertical. I should be able to click on this line. I think I can hold shift and click on the other line here. Now you can see it's a little bit different than BobCAD. You would be familiar with chain selecting. If I hold shift and click on this vertical line here, you would assume that either the top or the bottom line would chain select with the others. In SolidWorks, you're just adding to the selections here when I hold shift. So I've got this line here and this line on the left, and I can now add a relation here. You can see the option just as we had vertical. We could make them parallel to make the sketch defined again. What else? What other relations do we have in here? We have horizontal, vertical, collinear, perpendicular, parallel. You can make them an equal length to each other, and you can also fix an entity to a certain position, just like I have this bottom left corner fixed to the CAD origin location. And then I can click OK to close the dialog box there.
Perfect. Yeah. Thank you for going over that. I think it's again it's the basics of drawing in SolidWorks. Is understanding that you can create relationships between different geometries, and from that point on, everything you build, you can just change it as you go. So keep going.
Okay, yeah, let's keep going with this one. Very similar to what we have as our example file here. Now you can see when I minimize that file in SolidWorks, down at the bottom left, we have our different files. We have our 5-axis file that we saw, and we have our pocket example. So basically, how I'm going to create this in the new file is just do an extrude boss down, then make a smaller rectangle to do an extrude cut, and then do a couple of shapes here to do an extrude cut down further down from there. So from the sketch, we could go right here a couple different ways. I could simply go into the features tab, which is to the left of the sketch tab here, and go to extrude boss. It goes right into the extrude boss function. I could also go exit out of the sketch, and then in my feature tree, I could right click on the sketch. And
Eric, I don't know if it's me, but I can't hear you anymore. So check out your audio, please. Let me check. Maybe to make sure that maybe
okay,
the
is that better?
yeah, now yeah, we lost you for around like a minute. So if
Okay,
you can come back.
I think my headset isn't working perfectly. So, a couple options with the extrude boss here. If I go to my sketch, I can highlight the sketch I want to extrude and go into the extrude boss function. I can also do it while I'm in a sketch, while I'm editing one. It goes right into the extrude boss function for that sketch there. And you can see the options just like in the standalone version of BobCAD. We can go in the positive direction in Z. We can also go in the negative direction in Z by clicking reverse direction here. And I can click on this arrow and drag my cursor down to move the depth of the extrude boss. And I can also type in the number over here in this data entry window here. And then click OK. So now I've extruded it down 2 inches. Then I want to do a pocket, just like my example file here, with a smaller rectangle, and then a couple other pockets right there. I'm going to go into my sketch tab up at the top again and go to the sketch function. Now I can select a surface I want to sketch on, and I can also drop down the feature tree right here and select which plane I want to sketch on as well. And I'm going to sketch on the top plane again. I'm going to go to my rectangle function again. And this is the most common one in SolidWorks, clicking on one corner, clicking on a second corner there, and then going to my smart dimension function to select my width of the pocket here. Let's do 1.25 inches and click OK. And then for the
Would you mind doing it a little bit differently? Instead of setting
sure,
up the distances of the rectangle, how
yeah,
about we use our smart dimensions so we connect it or create a relationship between the big one and the small rectangle. That way, if we change the size of the big rectangle, the inner areas is going to stay the same. So I think it's a really good example to show how relationships are important in SolidWorks.
yeah, absolutely. So we have our dimension of the rectangle here. I'm just going to hit undo once up at the top, and I can change uh, the dimensions from the actual rectangle here to maybe let's do the corner of the original rectangle
You can do
to
it to the side, so it's in a specific, like from
the
center to
side.
center. Hmm.
Sure, yeah. Like side to side here. Is that what you
Hmm.
were
So you
thinking?
go to smart dimension, and
Smart
then
dimension.
pick center and center. Yeah.
Yeah.
So it always will be that distance between
Hmm.
those two you can set up like this is half inch, and you can have half inch on the top and half inch on the bottom. That way,
Right.
if we change the size, it will always be half inch from the corners.
Right. Yeah, we'll always have a half-inch wall thickness, even if we change the outer perimeter of the boss or the pocket here. And I'm going to do the same thing for the other sides here. Just click on this line and then click on the bottom of the extrude boss here. Type in another half inch and hit OK. Still underdefined, so I think we just have to do them for the other two sides. Select them like this, 0.5, and then select them like this here, and 0.5. And now all of the four lines here are black, saying that they are defined. And then we could go into the features, to extrude cut, and then let's do 1 inch pocket, extrude cut through there. And then, like you said earlier, if I go back into my extrude boss, and let's edit the sketch, change the dimensions here. Let's do 3.5 instead of 4 inches for my total length. And we could do 1.5 for the width of the extrude boss. It updates the extrude boss automatically, and it also updates the extrude cut so that it keeps the half-inch wall thickness all the way around.
Exactly. And again, we come back to the importance of SolidWorks, and basically that's the biggest differentiator between BobCAT and SolidWorks. Is you could do this part in BobCAT just as fast, just as easy, but coming back and changing it with relationships like we're doing it right now, it will be harder. We'll just have to redo the whole thing or just change the shape on its own.
Right, exactly. All right, and then if we wanted to make the changes again, we go back to the sketch of the extrude boss. I'm going to make it a little larger so we can see the pocket a little bit better here. Let's make it 6 inches for the total length, and let's make it 3 inches for the width of the extrude boss. So we have a larger pocket so that we could do another pocket inside of it. Now I could go to my sketch function, and instead of sketching on the top plane, I could sketch right onto the surface of the first pocket so that I'm at that original location, and from that location I can extrude cut from there. And I can say, let's do a circle, and the circle function is a little bit different than the BobCAD function as well, where I can click on a center point and then move my cursor out and click on the radius of the circle. And then I can go over and type in, even in my parameters, very similar to BobCAD, I can type in my X coordinate location for the center point, Y coordinate location, and the radius. I can go into my smart dimensions, and I can say from the side of the pocket here to the center point of the circle, let's make that 2 inches. It's still blue, saying that it's underdefined because we still need to move, or we still need to define where it is in the y-axis here. And so then I can go to my smart dimension function, and let's say from the center point to the bottom of the pocket, I can make that 1.5 inches. Still underdefined because when I click and hold on the circle, it's still asking me what the actual radius is there. And so I'm going to go to my smart dimension, click on the circle itself, and then I can type in the diameter is what it normally asks for. So I'm just going to type in 1 inch. and that's right on the edge of the uh, pocket. So I'm going to change the dimension down below here to just so sort of centered up there in the y-axis at least. If I didn't know the distance from the side of the pocket to have it centered, I could get rid of this dimension by highlighting it and hitting delete. And then I can click on the center point of the arc, and then I should be able to click on the midpoint of the edge right here. If I can zoom in and find it, I can hold shift and click to add that to my selections. And I can give me the point there of the side of it here. So if I hold and it doesn't give me a really good option there, but I could get the side of it. Let's see. There we go. Now I got the point, and then I hold shift and click on the center point of the arc, and then I can make them vertical to each other, center it up. And then it is defined. I can go to my features tab
At that
and go
point, you wouldn't need the other dimension because it's always going to be centered to that position.
right.
Mhm.
Yeah, centered from this point to this one, and then with that dimension, I would want it centered from this point to this point, so that it's centered in the x direction as well. To have the whole here always centered uh, to my model. And then I can go to my extrude cut, and I can extrude cut it down. Let's just go a ½ inch here. Perfect. So very similar to what we had with the pocket example there. I'm going to minimize this. Well, now let's just stick with this example here that we're working on, so that if you're following along, you can see the relationship to what we have here with this 3D model, and in relation to the BobCAM for SolidWorks plugin, and how we can modify the geometry here, and the toolpath in BobCAM for SolidWorks uh, will also update based on your geometry you created here and modified. So if we go to BobCAM, the BobCAM tab up at the top here, we also, if you don't find it, if you already have it installed and you don't find the plugin just yet, you can click on the add-ins. That's the gear icon up at the top here, and click on add-ins. And you can find BobCAM for SolidWorks down at the bottom. You can make it active with the checkbox on the left, and you can check the checkbox under startup. So every time you start up SolidWorks, it will open the BobCAM tab up at the top automatically. And then up at the top, we go to a new CAM job. We'll select it as a milling job type. We offer turning for a lathe. We offer mill turn for a lathe with live tooling. We offer wire EDM machining as well. Under the milling job types, we also have machines for milling machines, routers, as well as laser, plasma, and water jet machines. We support all of those different types of machines as well. We're going to go with a BC3X mill, so that stands for BobCAD 3-axis mill, and I click OK. I can select my workpiece, so that's my finished 3D model here, so that I can see that in simulation and make sure everything is cut to size. I go to my next page, where I can define the stock that I'm starting with. I can change the parameters here, enter the dimensions of the overall stock width, length, and height, and different stock types as well. If I want it to be a cylindrical shape, if I want it to be, maybe it would be extruded a little differently like this around
So
the
this is pretty
solid.
much the same as Bobcat V37. Now,
Yes.
um, Are there any functionality differences between 37 and BobCAM B12?
Not that I can think of at the moment, since you mention it. It's all the same workflow as defining the stock, next page defining the machine setup, and then when you hit OK, you have your cam tree over here, just filled in as as another tab, just like your feature tree in SolidWorks. You tab over to your cam tree to be able to create your milling job, define your stock, and define your milling operations under the machine setup, just like the standalone in BobCAT.
Okay.
So yeah, like you said, it's basically the same exact workflow as the standalone version BobCAT B37. We have our drilling and tapping features. We have our mill 2 axis, where I could do a pocket first, just selecting my geometry
Mhm.
and selecting these 4 edges.
I think you can pick the surface itself, and it knows the depth when you use using SolidWorks. So
Right.
that's gonna save you a step of defining the actual depth of the part. And something else that it's important, maybe you could go back into the CAD and show a little bit about the being able to not only because the point is to show SolidWorks and how we can add drilling operations. SolidWorks has a drilling library, so you can add your holes with specific properties. And
Mm-hmm.
now BobCAM for SolidWorks, something that it can do is read those properties to have them shown in our system, so it makes it easier. And something that will be cool too is to show how you can make a drawing out of this, because it's something that the customers are always asking us on how to do. Like, um, you can make a drawing in BobCat, but
Mm-hmm.
it's not as simple to make it like you can do it on SolidWorks. And in SolidWorks, you not only can create the drawing, you can send it to somebody else and have them participate on the drawing. So I think those will be really cool things to show our customers that they're not only going to have a parametric system that has relationships between geometry, but that we can actually have whole libraries included with the system. Those whole libraries will be recognized by BobCam, and you can make drawings because it's a huge deal. Drawings and assemblies; those are things that we want to show our customers and define so they understand the differences.
Right. Absolutely. So, just as you mentioned in the beginning there, being able to select the whole body, meaning selecting the solid model, and it will pick up uh, first feature would be a facing operation. It understands that depth, then it understands the depth for the pocket, and then it understands the depth for the hole there if we wanted to use an end mill to mill that out. So we go to our machining strategy page, which we would have a facing operation first. Defining the facing tool, I'm just going to make the tool a 2-inch diameter and set my spindle RPM and cutting feed rate. And you can see all of the same pages and the same workflow as our standalone version. A zigzag cut pattern, step over of the tool, a lead in and lead out page. And then we scroll down to the total depth, where it picks up the total depth of the first pocket, the rectangular pocket there. And we would do a pocket and then a profile finish pass. We would define the roughing tool, make it a 1/2 inch end mill. Scroll down after selecting the cut pattern of the pocket, the depth of cut if we want to set that. Let's do a couple of passes down with a depth of cut of a 1/2 inch. And all of the same pages as before here. Then we get to the finish tool. Let's use a 1/4 inch flat end mill. And then scroll down to the next feature, which will be the top of feature from our rectangular pocket here to the depth of a 1/2 inch of the cylindrical circular pocket.
Okay, Eric, I'm gonna go,
Wow.
but I'll
Okay.
leave you here. but please just make sure that they see those big differences on the CAD area. And thank you for preparing this for us.
Yeah, no problem. Thank you for joining us today, Tatiana.
Oh, have an amazing day.
Thank you too.
Bye.
And so once I hit compute with this feature, you can see all of the features load into the CAM tree automatically, just based on the 3D model that I have. So if I go in and see the facing operation, highlight the pocket and profile finish, and highlight the pocket and profile finish for the circular pocket, I can see that there's no toolpath for the circular pocket. I need a smaller tool than that 2-inch face mill, flat end mill, and we'll also do multiple depth cuts there. And if I want to see a certain operation, I can right click on an operation under the feature, and I can backplot it to show the tool down into the pocket here, and I can step through and see the current tool location at every position in the G code there. Then I click OK to back out of that. So next will be modifying the geometry, and the toolpath will automatically update in the plugin BobCAM for SolidWorks. So I go back over to the feature tree, which is basically the CAD tree in SolidWorks here. If I were to use another BobCAD term there, the CAD tree or a feature tree here, I go to my second extrude cut for the I'm going to go to my first extrude cut for the rectangular pocket, and I'm going to edit the sketch. I'm going to change the wall thickness here to make it an open pocket. So I should be able to just double click on it, hit 0, so that it extrude cuts all the way to make it an open pocket there. I click OK. It updates the 3D model for me once I back out of the sketch function here. And now it creates the pocket. Once I click on the CAM tree, there will be a message that prompts from BobCAM, and it says the model geometry has been modified. Some machining features may no longer be valid. Do you want to auto-update the CAM tree? And when I click yes, it auto-updates based on the pocket, the opening there. Now, it doesn't necessarily start with a side roughing routine, and the reason for that is because when I go in to my patterns, it has to be one of these advanced pocket options. So if I change it from standard to advanced and click compute, it'll start from the outside of the stock now and work its way in from that opening. And I can even see that in my backplot now. So you can see when you modify the geometry of the sketch and of the 3D model, it will automatically update the toolpath in the BobCAM plugin there. Cool. And then we can go in. What do we have next? We have the design for a hole. So if I wanted to set this up as if I wanted to drill it and do a threading operation and things like that, I can go into my, I believe it's under the sketch function here, under the features, I can select it as a hole, and that is under that's a good one there. Oh, hole wizard. There it is. It's right next to extrude cut. So you have your hole wizard. There's a drop down there. You have your hole wizard, advanced hole, thread, and stud wizard. So we're going to go to thread location. I'm going to select the edge there. And then below that, I have my specification type. So if I wanted it as an inch or metric, I can then select the size of the thread. And I'm going to do, let's see, that was a 1-inch diameter of the hole. So let's do 1 inch 8. and then click OK. And then you can see the BobCAM message prompts. It says it's been modified. Do you want to auto update? You click yes. There's nothing that will really update for that because we haven't changed anything necessary to update the toolpath. But then we can go in and we could right click on the machine setup, go to mill thread, and add that into the toolpath as well to be able to view that in our simulation. But before we go through that, let's look at the simulation and see everything cut to size before we get to the thread here. I can right click on the milling job, and simulation is 6 down from the top. I click on simulation. And then I go and sort of revolve it around here. We have our facing tool first. I can hit run, and I can speed up the simulation run speed here. So it does the facing first, then it does the pocket by starting from the outside of the stock, working its way in, pocket down to there, and then using the 1/4" tool for a profile finish, and a profile finish down into the circular pocket as well. Up at the top here of our simulation, we can see the estimated cycle time. It says that will take about 40 minutes and 39 seconds to do these operations, and that's based on the feed rates, based on how quickly the tool is moving about, and getting our cycle times from that we calculated. If I wanted to change the cycle time, obviously I could change the feed rates on every tool page of every operation in the CAM tree. I can also change it from time mode to NC mode. It will tell me how many lines of code this will take in the G code, about 331 lines of code. Drop this down again, and we have length mode. And it says the tool travel, about 149 inches of tool travel to machine this part. Then we can see in the corners, there's obviously an arc in the corners here because the circular tool is not able to fit into the corners any better than the 1/4" tool that is able to fit into the corners here. And also we don't see the thread yet because we did not create that thread operation in the CAM tree yet. But before I modify any of that, I can see how much material is remaining to get to the workpiece that we defined from the beginning of the operation, beginning of the milling job here. Down at the bottom right of our simulation, there's this yellow tab labeled Analysis. I can drop down under the Analysis tab and go to Deviation and hit Refresh next to that. There's a refresh icon. Now it will show me different colors on the stock depending on how much material is remaining to get down to the workpiece I had defined of my 3D model. I can see everything is cut to size with a cut tolerance of plus or minus 0.008 of an inch here in green. I can zoom into the corners here of the pocket and see that this teal color is anywhere between 8 thou to about 26 thou remaining. And the lighter blue color here is anywhere between 26 thou and 45 thou remaining. I don't know if you can see those colors or the definitions there, so I'm going to move myself to that top right corner now. Now you can see the green here, where my cursor is, plus or minus 8 thou. The teal color here, 8 to 26 thou. Light blue color from 26 to 45. You can see this darker blue color of anywhere between 64 thou or more remaining, which would be much more material to be removed. Now I can zoom into the thread and I can see all of that material remaining as well. So if we wanted to remove that material of the thread that we had modeled in the 3D model, we would right click on the machine setup one, go to mill thread, and then be able to select our geometry from there. I think we can even select the thread. Can we select it from the CAD tree here? Yes, we can. So we can select it from the feature tree in SolidWorks by dropping down the feature tree right here and selecting thread 1 as our geometry and clicking OK. Still doesn't highlight, so it might be beneficial if we just select the solid model there, and it should pick it up. There we go. Now it understands the diameter, it understands the depth, it knows that it's not a through hole. So all of these numbers are updated based on the geometry. And I select mill thread here. If we're doing many threads, we can select the most optimized way, or we can pick the order manually or in different directions. Select the tool. Select whether it's an inside or an outside thread. If I'm starting from the top down or working from the bottom up. We have a side roughing option here to set the number of passes and how far it's going to step over each time. And our compensation, if we want to turn that on, or if we want to set the compensation left or right under machine compensation, which would give us our G41 or G42 output in the G code. Then we type in the diameter, the thread height, the thread pitch. We can also type it in manually or select it from our thread library. Set a lead in and a lead out. And MDI for every operation page in BobCAM for SolidWorks. And MDI stands for manual data input. If I wanted to add any miscellaneous G or M codes or any comments into the G code program here manually from the feature page. And I click compute. And there is in blue the lead in and lead out down at the bottom. And if I backplot it, you can see where it starts. Very stubby tool. Might have to make it longer so that the tool holder doesn't crash into the part there, but that is how we can backplot it. And then if I need to change that for my simulation, I just right click on the feature, hit edit, go to the tool page here, and I can either go to my tool library from the tool crib, or I can just uncheck this box system tool and modify the tool on the fly here to just be able to change the overall length to 3 inches, change the protrusion length to 2.5 inches, and click OK. So when I backplot, it looks a little bit better for us there. So yeah, if you guys have any questions overall with what we've gone over so far, please let us know in the comment section. That comment section is going to show you our technical support contact information. Our phone number there, 727-489-0003, and our email address, support@bobcad.com. So if you have BobCAM for SolidWorks or something with our standalone version of BobCAD, and you have technical support, you can call into that number and ask us any questions that you have when you're working into the software program. It's a first come, first served basis, so you get put into the ticket system, and we call you back, and we can log in and answer any questions that you may have. Now, next would be the assemblies and also the drawing features in the SolidWorks software program as well. So let's say I've got this as my model. I want to go to save it as a SolidWorks part file. So that's SLDPRT. I'm going to save it into my downloads so I know where it is. Would you like to rebuild a document before saving? Sure, let's rebuild it. And then we hit save. And then next, we can create many other parts to be able to set it up in a vise or any, maybe there's some clamps that are involved with your milling workflow there at the machine. You can model those in SolidWorks and create it all as one assembly and be able to program in BobCAM for SolidWorks and in a SolidWorks assembly file and be able to make sure in simulation that there's not going to be any collisions with clamps, with anything on the fixture side, with the vise, or anything else involved in the machining process there. So I've saved this part file. I'm just going to do a couple basic shapes to be able to model, to be able to have a couple other part files and import them into an assembly file. So I'm going to close out of this file for now. I'm going to close out of this complex shape that we went over earlier and close out of the example file here as well. I'm going to go to a new file. Here's where I can select a part file. We'll get into an assembly file next and then get into the drawing files after that. I'm going to click OK. For a new part file, I'm just going to go to Sketch and I'm going to sketch a basic rectangular shape. I'm not going to get too crazy with it because this is just, like say some soft jaws that I'm going to have on the vise that I'm going to clamp or fixture this this piece of stock into to create the milling job for my part. So I'm going to create a rectangle. I'm going to go to Smart Dimension and make this 3 inches. We'll make the top line. Oops. We'll make the top line. Let's do 8 inches. Let's go a little bit longer for the other side there. Let's go 12 inches. I'm going to go to Features and go to Extrude Boss. And we'll make it, I'm going to extrude it down. And click OK. Then I'm going to save this as a part file as well. Part 2. My original was part 1. I'm very creative with the part file names there. And then I'm going to close out of this part file as well. I'm back to my home page for SolidWorks. I'm going to go to a new file, and I'm going to go to a new assembly file this time and click OK. And now it's asking me what SolidWorks part files do I want to open into a SolidWorks assembly file. So you could think of it as like a folder of many files that you can import into an assembly here. So we go to Downloads and we go to Part 1. Open up my original. I'm moving my cursor around and it's asking me where I want to place it down. So I'm just going to place it down. And then next, I'm going to add a couple of those part 2 files on both sides of the original part file here to have it as, a couple of soft jaws on the sides or a couple of jaws as my vise that we can model here. And I go to, where do I go to? I think I just right click here, right? Part 1. I can mate things. I know the easiest way. I'm thinking of how to do it here from the feature tree. I usually don't do it from the feature tree. What I normally do is I just go to my File Explorer. I go to my Downloads. I find Part 2, and I can drag and drop it right into SolidWorks like this as well. So that's a little bit easier. That's how I do it, at least. And then I can also zoom out a little bit. There we go. There we go. And then I can drag and drop part 2 again and place it on the other side, right into SolidWorks. Go back into SolidWorks. And then now I think I can just drag and drop them, or I can drag them inside of the assembly file. So I've got an assembly. I have, to sort of reiterate, I have a SolidWorks assembly file here with 3 different SolidWorks part files inside of it. I've got number 1 as part 1, this next part as part 2 and this next part file as part 2, just the second one here. So I can drag and drop them, try to fit them right next to each other. Or I could also create references just like I did in the sketching to be able to reference and have this part here, the side of the jaw here of the vise. I click on the surface, rotate around a little bit, hold shift and click on the side surface here. And let's see, there should be a reference option that pops up. There's an edit part option. Oh, here we go. So I can actually click on part 1, hold shift and click on part 2 here, and then I can right click and I can mate them. So we have mate references is what they're called in assembly files. That's the icon of the paperclip here. I can select, let's see, so both of them, multiple mate mode, entities to mate. Oh, entities to mate. I think I just select this surface here. Nope. Standard advanced mate type. Oh, here we go. So I scroll down a little bit and there's this window here for mates. I should be able to, why are they locked? Oh, I think there's one other weird one here with SolidWorks to right click on the original one. And when you see a letter next to the part in the assembly, the letter F means that it is fixed. So you can right click on it and you can change it to float so that now you can move it around, and you can also change the mate references for each of these, I believe. We can delete this. We can lock two components together. I don't want to lock them together. How do I view mates? Yes. And yes. And then let's try that. Now, usually I should be able to like select certain things like this. Mate references. Oh, there we go. Perfect. Okay, cool. So, all right. So I can select a point. So I'm going to make these coincident to each other. I'm going to make the, let's see if I can get the center point, the mid. Let's just make them coincident to make this easy for us here. We can click on the top corner of this part. I'm going to click on the bottom corner of this part here. I'm going to hold shift and click. Click on that one. Now we have both of those points there. And now I can right click and I can make them together. That's the workflow of that. And then do it the same thing on the other side. Just click on this point. Once I've gotten out of that, click on this point here, hold shift and click on this point. And then now I can right click and go to mate, and it will mate them to that location. I can make them coincident. I can, I just went back to lock. I can make them coincident. I can make them vertical to each other, so it'll move it over in this direction here. I can make them horizontal to each other. I can also, what other options are there under mate references? You can see coincident, parallel. You make them perpendicular to each other. You can also set them to a certain distance here. So if I wanted to move it down a little bit further for my jaws in the y-axis and then move it up a little bit in z so that there's something holding on to the part there, you can do that as well. And then you click OK to finalize that. Next, we're going to get into, that's about it with the assembly file for today. We can, again, create multiple parts like this, add them into an assembly file, move them around so that, and then now they're all mated together. So when I move one, the others are locked into each other and they all move together. Now, I'm going to create a drawing for my original part file that we created here as well. As Tatiana mentioned, we can create a drawing. It's creating, in SolidWorks, it's called a drawing, but basically it's creating a print. And then you can send that print over to another customer or another person that has SolidWorks, another end user, and they can modify the print and modify the dimensions on it and change the revision number, those kinds of things. We go to a new file in SolidWorks and select drawing and click OK. We can select the sheet size and the format of it here. A couple different options. You can also create your own. I'm going to go with the first one here and click OK. Now you can see it's very professional. You zoom in and you can see the drawing number, which is the file name first. You can set the scale. You can type in your name, signature, date, and all those cool types of things there. I'm going to zoom out to see the drawing again and see the border of it that it brings in. Now, over on the left-hand side, it's asking me what part files do I want to bring into our drawing here. I'm just going to click on Browse, and I'm going to scroll down to Part 1 and click Open. Now you can see this rectangle is going to be, I believe, the top view. I can see it over here. That is the front view of it, actually. I can see, and then if I want to change it, I can change it to a top view. I can change it to an isometric view and different options like that. I'm going to start with the front view. That's the default option there. And I'm just going to click anywhere in the drawing here to place it down. And then I'm going to select, let's see, I want the hidden lines showing for, let's see, I select hidden lines visible so that I can see the hole in there. I can also, I actually want to select that before I place the first one down. So if I want to delete something, I just get out of everything, click on it, and then hit delete. And then I just go back to adding a new. I think I can do the same thing as I did before, just drag and drop it in. Yeah, there we go, perfect. And then I can scroll down, make sure I've got hidden lines visible. I've got my front view. Is this part 1? That was part 2. Darn it. I want part 1. So I'm going to delete that again. So drag and drop part 1 in. There we go, perfect. I'm going to have it there, and then select hidden lines, and click OK. And now you can see the hidden view of it is with the thread in the center here. And then I can double click on it and I can, let's see, how do I, normally there's a way to like add more part, open part in position. That opens a part file. Normally there's a way to let's see, once I click down on that, then I can also dimension things. So once I click OK out of that, I can go to the top, go to Smart Dimension. Let's say I want to dimension the thread here inside of the drawing. Let's say I want to dimension the width. I just select it and then put it down below the diameter there and place it down there. And let's get the height as well here. And then we can go in and I think easiest would just be dragging and dropping that into here again, selecting an isometric view. And so it gives me the isometric view here in the top right. It gives me a top view down at the bottom here, just like normal for a drawing. And then I select hidden lines. And then I click OK. And then I can zoom in and I can make more dimensions here. So now I've got the pocket on this front view with the hidden lines visible. I can go back to my smart dimension. I can get the height of the pocket, and I can get the total distance of the pocket as well from that side there. So a lot of cool things to be able to model or create the drawing here, create your print. You should be able to double click on one of the drawings there and change it to like a solid here if you wanted to see the isometric as a solid there. You can also, there's also options in here in the print to be able to add a bill of materials with all of your parts in here. So you can create your assembly in a drawing and add your bill of materials. You can add all of those other parameters here at the bottom right corner of your drawing. And again, you'd be able to save this. First, once I save, sorry to go back to the assembly for a second. With my assembly, I would save it as a SolidWorks assembly file. That file extension is .sld for SolidWorks and ASM for assembly. So that's .sld ASM. And then you'd be able to send it to another person that has SolidWorks to be able to open up the assembly file. And as a drawing file, you can go here and you can save it as a SolidWorks drawing file, which is file extension .sld drw. And then that way you can save it as a SolidWorks drawing file so that any other person that has SolidWorks can open it up and modify the drawing, modify the bill of materials, modify the assembly here in the drawing file to save it and send it to anyone else. And that's about it with the webinar today. We went over how to create a SolidWorks part file, how to program it to create the toolpath for your milling job in BobCAM for SolidWorks. Same kind of workflow as our standalone version, which is really nice. There's not any kind of learning curve to programming here in the plugin for SolidWorks. Once we saved our SolidWorks part file, then we also made a part for the jaws for the vise and went into creating a SolidWorks assembly file, creating mate references and changing the location of the jaws and changing the mate references with this here. And then we also have gone over creating a SolidWorks drawing file to create a print, save it, and send it over to another end user of SolidWorks. So if you guys have any questions with what we went over today in the live event, please let me know in the comments section before we finish wrapping up here. And I want to thank everyone that joined us today live in the live event. We are live every other Wednesday for these webinars. And today is March 19th. So our next webinar is on April 2nd. And the topic is to be determined. We send out a survey to our customers to see what they would like to see in our next live event and make sure that these live events are tailored specific to your needs in the software program, whether it's the standalone version of BobCAD V37 whether it's the SolidWorks CAD software program or the plugin BobCAM for SolidWorks V12. And I want to thank everyone again for joining us live today, and we hope to see you in the next live event, April 2nd, 1 o'clock p.m. Eastern Time. Thank you. Have a great day. See ya.